factor completely. This first example, x to the fourth minus 16, appears to be the difference of perfect squares. We always try and factor perfect squares before we try and factor perfect cubes. The way that we break down x to the fourth is an x squared times an x squared. So we can put 1 in the front of both parentheses. And the way we break down 16 is 1 and 16, 2 and 8, 4 and 4. So we'll start at the end of the list and put a 4 in both sets of parentheses. The last term is subtracted, so the signs are different. One's a plus, one's a minus. X squared plus 4 are perfect squares, but they're added. And the perfect squares added does not factor over the real numbers. Looking at x squared minus 4, that again is a perfect square, so we can factor again, putting an x in the front of both parentheses and a 2 in the back of both parentheses, and the signs are different. One's a plus, one's a minus. 64x cubed minus 1 should be rewritten. This appears to be a cube, the difference of cubes. So 64 happens to be 4 cubed, x cubed minus, and the number 1 times the number 1 times the number 1 is still 1. So that's 1 cubed. When you want to factor the difference of cubes, you write what you see without exponent 3, 4x minus 1, and then a large set of parentheses. The first thing we're going to do is square this first term, giving us 16x squared. Then we multiply them together, giving us 4x, and then we square this last term, giving us a 1. The last sign is always a plus, and the other sign is the opposite of what you started with. So here we have subtraction, so inside the large parenthesis we'll have a plus. And that's how we factor the difference of cubes.